The final example in this tutorial explores a different type of input. So far we've used mouse input to control these models, and this time we're going to use sound instead. What's happening then in this patch? We've got sound coming in through the microphone, through this ADC function, and then this signal is being analysed using the spectrum analyzer, the FFT. What this does is it examines the amount of energy in the frequency bands across the spectrum of the sound, and we get an array of data about the energy in these bands in this variable f. Here we choose 5 of these frequencies, so I'm trying to keep the data small that's going into here. We don't need all 128 of these frequencies. We're just going to choose 5 that kind of spread out across the lower end of the spectrum, and they're getting sent over to the model. And then we're taking 3 parameters back from the model. This is a bit similar to the first patch in this tutorial. There's a bunch of detuned saw oscillators. I've expanded the range of them a little bit, so it's a bit more obvious the changes we get in the sound. I'll run this patch just so we can see what it sounds like. Alright. Now I'm going to train the synth much like the same process we've seen already. Now I'm going to train the synth using 2 sounds. These sounds I've chosen because they're quite different, so hopefully it'll be easy for the neural network to differentiate between them. The first sound is a kashishi, and the second sound will be whistling. So hopefully we can, the neural network will be able to kind of map these different sounds to different sound settings fairly clearly. So here we go. This initializes the network. I'm going to choose some different sounds and associate them with these input sounds. That's the data collected. Now let's train the network. That creates the model. This converts the data format. And now we train. Let's try out 10 epochs first and see how it goes. Alright, that's pretty low actually in 10 epochs. So let's run the model and see what happens. So hopefully when I whistle, we should kind of move to one sound, and when I wrestle, this kashishi here, we should move to another sound. It should also probably pick up the sound of my voice and modulate the sounds in return. And as I speak, hear the mapping getting mapped, my voice getting mapped to the neural network back into the sound. So I don't know if that came through on the video, but as I spoke, my voice was it was picking the frequencies up my voice and mapping those back into the sound synthesis. So again, that kind of shows another example of how we can use this parameter mapping quite creatively. We're not just don't have to just use mouse movements. We can use anything that produces a signal, basically. So that the possibilities are fairly endless. So that really brings this tutorial to a close, and the main point being that this script here is really configurable, so you can go and use it with your own projects.